couple more people join. Thank you guys for joining. Yeah, super excited for this hackathon workshop. John has been part of Brunei AI for over a year, where he led an event with Cisco, and that was like extremely fun.
Thank you so much. Thank you so much for having me, Karen, and for organizing this event and for having me. Thank you for everyone here. So, a couple of things just to get started. I don't want this to feel or sound like a lecture at all. I would consider you all peers and equals in that we're exploring and passionate and interested in using a relatively new tool that humans have in the past just few years, and how we can make the world a better place, how we can, improve society, get better jobs, make more money, possibly start a new $1 million company. Okay, so we're going to be talking about basically new protocols today. I'm not going to get into large language models or OpenAI or ChatGPT too much. I assume that there's a nice level set of general AI knowledge in the crowd, but there is some brand new stuff, quite literally brand new, that I'm going to be exploring with you. And for your hackathon, I think that these are things that you could actually really accelerate your hackathon project and come up with something exciting. So we're going to be talking about model context protocol. Karen, you know what's funny? In the time that we made this slide and today, a new protocol has come out called agent to agent, and we're going to be exploring how model context protocol and agent to agent work together. They're not competing standards. So a little bit of introduction, who I am, what I do, how did I get here? John Capobianco. I'm currently a product marketing evangelist for Selector AI. Now, Selector AI is an artificial intelligence operations platform that monitors and does root cause analysis for major internet service providers, large enterprises. We monitor the infrastructure and use machine learning and AI to identify problems and even how to solve problems and come up with the root cause analysis. We have a co-pilot, so a natural language interface where you can say, how is the wireless in Denver in natural language? And that will assess the wireless in Denver and give you a human-like response. I was formerly an artificial intelligence technical leader at Cisco. Prior to that, I was a senior network architect for the Parliament of Canada, the House of Commons. I was there for 9 years. And prior to that, I was a senior network engineer for an insurance company in Canada called Empire Life, where I ran the network for about 7 years. So how did I transition from networks into artificial intelligence? It actually is not that big of a stretch, because there's a gap between traditional networking and artificial intelligence networking called network automation. And I was one of the early adopters of network automation and using code and Python and infrastructure as code to automate network solutions. And now artificial intelligence, I think, is just an evolution of automation. Okay, to be honest with me here, is anyone doing vibe coding? Does anyone on the call consider themselves a vibe coder? No? Do you know what I mean by vibe coding? Has anyone heard this phrase? Okay, so I'm going to be introducing vibe operations to the world. So coding is developing software, but vibe operating using large language models and model context protocol and tools and AI agents, where we can literally chat with our infrastructure to make it better, to fix problems, to add capacity, to make changes, just vibing, just chatting with it. All right, so we're going to look at model context protocol, MCP, and agent to agent today. So protocols made the conversion from analog to digital possible. I'm from that generation. I'm Generation X. I'm 47. I was born in 78. My first computer was in 1984, a 286 IBM clone. But it was these protocols that moved us from an analog world into a digital world, to the internet, to the World Wide Web, to mobility, to cloud and streaming, and now artificial intelligence. Do some of these protocols jump out at you? IP, the internet protocol. Right now, this call is being facilitated by dozens of these protocols that are the standards. Now think about this. Why protocols? Why would companies share intellectual property with each other and share the way they do things and share the way they implement things? And everyone agrees to do things a common way. There's a lot of benefits for this because let's take networking, for example. If I'm Cisco, Juniper, Arista, HP, Dell, all these big companies want to sell routers and switches. But it doesn't do the world any good if Dell's router doesn't work with Cisco's router. Or if you own an HP network and I own a Juniper network, but our networks can't communicate with each other. That's siloed. That's bad for a lot of things, right? It's bad for society. It's bad for capitalism. It's bad for progress and innovation. Not to say that protocols don't get displaced by newer protocols. That's evolution. If we take routing information protocol, RIP, the original protocol was almost obsolete as soon as it came out. It had big deficiencies in the protocol. So RIP v2 came out, which was an improvement on RIP v1. Some of you may not have lived through some of the competing standards, but we can think of it today. Think of iPhones and Androids, right? They have their own way of doing things, but we can still make phone calls between them because of protocols, right? Now, I put the OSI model. Have you been exposed to the OSI model in your studies? Anyone? This model that I have on the screen, has anyone seen this before? No?
We're getting some responses in the chat.
Oh, I can't see the
I'm not
chat.
sure
There
if
we
you can
go.
see.
There we are. Okay. Okay, yes. So people have seen the OSI model. So I think this helps humans understand networking. This is not a protocol, but these protocols that I've listed, they fall under one of these layers in this model. So as we move from a physical wire all the way up to you browsing the internet in your browser, traffic is encapsulated and moves up and down this protocol stack. Now, this is not quite the way AI works, but I think I'm having a mental model of me using ChatGPT, what happens all the way down into the GPU, into the hardware. And can we understand that in sort of logical layers of what is happening in this process? So let's move along. Just a quick evolution of operations. If anyone's interested in, IT, information technology, operations, networking, et cetera. We started with traditional operations in, the mid to late 80s, all the way through to almost the year 2000, where we're using manual effort, people logging into devices and running commands manually, system logs, which is just a bunch of noise that you've got to sift through to find the problem. Simple network management protocol, and it really is simple. It's right in the name, a simple network management protocol. We move into DevOps. Now, DevOps comes out of something called Agile. I'm not sure if anyone's heard of the Agile Manifesto. Some of the top developers in the world got together and had a summit on how to better write software in the world. And they came out with the Agile Manifesto, which led to DevOps. The idea being that developers should also be able to operate. So there was a world where there were silos. If I was a developer and I needed a new server to host a web page on, I would have to work with the operations team to procure hardware for that. Virtualization comes along, automation comes along, and now that developer can go into a portal, click a couple buttons, and provision their own server. Okay, that's the idea here with DevOps. This moves into network and net DevOps, where now the developers are now doing networking and networking people are doing development. Infrastructure as code and automation. It's kind of cut off on the screen here, but at the very bottom is supposed to be AI ops, where we're moving, I would say not in the future, but today in the present, where we're actually using artificial intelligence to help operate our large-scale networks. Now, rapid change doesn't come in normal times. I think we hit an inflection point in November 2023 when ChatGPT 3.5 became available. And we're just a little bit past this inflection point, just a couple years past the inflection point. But you can see the drift happening. People adopting and embracing AI and doing things entirely new ways, and older ways of doing things starting to fall off of this after the inflection point. Now, if we think of these different innovations at scale, I'm trying to be cognizant of your generation and maybe the age gap between us, but we went through a computing boom. You know, before the 70s and 80s, having a computer, you had to be extremely wealthy, or you were a bank or a government or a financial institution in the military, and you had a mainframe. Home computers explode, right? Windows 95, the home computer era, the internet era, into mobility, into the cloud, now into AI. Pretty soon, narrowing AI, generative AI, and then a widening AI, AGI, you may have heard this called. Now, before I show you some screens and we talk about some of the technology, I get asked this quite a bit. What's my toolkit? What are the tools that I use on a day-to-day basis as a Vibe operator? I'm kind of joking, as an artificial intelligence developer. VS Code, but it doesn't have to be VS Code, an integrated development environment, an IDE. Has anyone used Claude Desktop? Is that the kind of development environment a lot of people are using today? Anyway, Git and GitHub are extremely, extremely important. Okay, VS Code and Cursor, awesome. So when we say infrastructure as code or any type of code, it implies version and source control. And to do version and source control, we need something like Git and GitHub. It's also a good place for Brew and AI to share your code. If out of this hackathon you make an incredible AI agent, you should host it and open source it on GitHub. Now, I use Docker for containers. Now, I'll show you real quickly. This is my Docker, and I'm running a bunch of containers, and you can see most of them are called MCPs. So I have an email MCP that's running in this Docker container that I can access as a tool. Now, Docker is a step beyond virtualization. So if we think of, I need a physical computer, or on that one physical computer, I can run something like VMware and have multiple virtual computers. Docker is a step further in that you can define a container as software. Let me just show you this. So here's my Docker file. And in 18 lines of Docker file, right, this is from Python. So this container can run Python code. And I'm going to install certain applications inside of this container, and then I can run this container in the cloud or on my local computer. Each service is being deployed as a web server, and MCP is essentially creating the interoperability. Pretty close. You're pretty close, Rishav. We'll get there. I'm really getting close to the MCP stuff. Kubernetes, once you have a bunch of Docker containers, you're going to want to manage and operate and orchestrate those containers. That's where Kubernetes comes in. I use a variety of LLMs. I'm really starting to like Gemini Flash 2.5 from Google, but I do use Claude and I do use ChatGPT. Is anyone using Llama for local free LLMs, such as Llama 3.1? Yes, good. Okay, some people are using Llama. ngrok lets you, so if I show you this little screen here, this is ngrok that lets me use my private local host port 10,000 and get it forwarding over the public internet so people can reach my agent. REST APIs, which are, I'll get back to REST APIs, and I think that might be a good place for some of your hackathon efforts, is to turn a REST API into an MCP and then turn that MCP into an agent, and then a bunch of other tools. So now let's get into some of these other tools. I would recommend for your framework to build an agent, if you're interested in building agents for your hackathon, I would look into LangGraph. It's free, it's open source, it's well documented, and it's quite easy to do. Let me give you an example of what the graph code might look like, and then I'll show you this visually. So a couple of things. Let me crank up the zoom so everyone can see this better. 1 second. Let me get to my graph part of this code. So in terms of the graph, it's down here at the bottom. 1 second. So I define an assistant, or it could be an agent. It depends on what you want to call it. I probably should have called it an agent. And then we have another node in my graph called handle tool results. And then we build this graph. So this code right here, technically, is all you need to build a graph, and then you're going to compile the graph. Now, what does this graph look like visually? Where is it here? Here. So this is my graph, and where the MCPs come in that same code, if I look for -MCP, this is called Docker in Docker. So this LangGraph itself is a Docker container, and it is going to call all of the other MCPs that I've found and connect it in. Now, MCP is like the USB-C of software. I found this email repository on GitHub. I clone the repository, I plug it into my solution, and then I add the one line of code, and now suddenly I can use that email MCP. It really is that simple. The USB-C, you just plug it into your solution. Meaning, you want to make a UCLA REST API MCP. I assume UCLA has some REST APIs internally for different departments. The science department or the whatever department probably exposes some REST APIs. You could take that REST API and make an MCP out of it, and the tool inside of that MCP would be a decorator for your REST API call, right? And then other schools or other faculties, other departments could take your science division MCP and plug it into the biology department MCP, and then plug it into the chemistry MCP. And now suddenly you have a hyper-connected UCLA agent that can talk to all the different UCLA REST APIs. So what we can do is, let's look at this a little bit closer. So I'll come back to this graph, but let's talk about Model Context Protocol. This is bleeding edge, everyone. You're right up against the edge of technology here. It only came out November 25th. Now, as far as protocols go, it might as well have come out yesterday. But there's already thousands of MCPs out there in the world. So look at this from Anthropic under their news article. It's only a 3-minute read. And then you can see that there's specifications and SDKs on GitHub, right? So you should read as much as you can on GitHub. And what's neat is if you're a C# developer, a Java developer, a Python developer, TypeScript, doesn't matter. There's an SDK for all of these different flavors and formats. And what's neat is inside of my MCP code here, some of these MCPs, like this one's Python. This one is JavaScript, TypeScript. In here somewhere is a full-blown Java one. It doesn't matter. They're all abstracted and will hyper-connect to each other. So even amongst your project team, if one person's good at TypeScript and another person's good at Python, you can make MCPs together. It doesn't matter. Now, okay, so let's get a little bit more practical here. If you go to modelcontextprotocol.io, and let me put this in the chat for everyone. This is a good resource, but they'll have lots of information. Here's what I'm talking about and what I was trying to get at. So it's client server, just like the World Wide Web. My Chrome is my client. My browser is the client, and there's an Apache web server out there hosting the HTML page, client server, right? Well, we have a client, an MCP client, that we just plug in the MCP servers into. These MCP servers could then talk to whatever you want, databases, REST APIs, Python scripts, whatever you want to abstract as a tool. Now, what's really neat is that your client will discover the tools automatically. So let's say you did make a UCLA sports MCP. In it, you might have a tool for track and field, a tool for basketball, a tool for football, right? A tool, and that tool talks to a database of sports data for your football team or a REST API or whatever. Now, boom, you have an MCP server for UCLA sports. And now you can make an agent out of that. Okay, we're about 8:30. I've got 15 minutes more of talking. Now, example servers, file systems, databases, Google Drive, GitHub, web searches, Slack, Google Maps, sequential thinking. And then if you keep looking and go to mcp.so, this is like a one-stop shop. You just go searching for MCPs that you can then plug into your solution. There's an awesome MCP server list on GitHub that's really highly curated by category here that is just full of MCPs. Okay? Now, let's just pick a random one. The Azure CLI MCP. You're going to git clone this repository and follow their instructions on how to use it. Here's how to plug it into Claude Desktop or VS Code or something, right? And then you could also turn it into a Docker. Does this come with a Docker file? See, this comes with a Docker file. So you could compile this MCP as a container and literally plug it into your Hackathon solution. Okay? Now, tools here and select tools. Has anyone heard of retrieval augmented generation? Is that a familiar term to everyone? Yeah? Okay. Here's the problem with MCPs and tool discovery. If I show you the logs of my server, all right, and this is just, let me get this out of the way, and go all the way to the top of my logs, you're going to see discovering tools for those MCPs, right? So as part of the natural process, I'm going to discover or list the tools from the MCP. So then, here is all of my tools that I have, something like that, somewhere in here. Discovered tools. Oh, hang on, I'm not even there yet, right? Just give me 1 second. There's a list here I'm trying to find that says bound tools. Anyhow, the point is that we're going to discover too many tools, and now the large language model, our assistant, is going to have trouble selecting the right tool. So what I've done is I've put all of the tools that I've discovered into a vector store, and I'm doing a similarity search based on the user's prompt to then pick the right tool to augment the answer. So, I ask my question, the select tools does its thinking, which then goes to the assistant and then picks the right tool, and we get the result. So if I do something very quickly here and say, where is Ottawa, Canada, lat long? One of my tools is a geo lookup. So see how it's going to select tools first? And then if I show you the results here, okay, it goes very fast. So let's just let this thing finish, and then I'll show you the logs. And hopefully it doesn't enter an endless loop. Should be done by now. Yeah, it's all done. Okay, so I asked the question and we at the start of the line graph. The select tools does a retrieval augmented generation and does a similarity search on my tools vectors and says, oh, there's a maps geocode tool. That's the closest matching tool. I'm going to use that tool. The assistant then calls the tool, which is an MCP that does the geo lookup from Google, and we get the final answer here of the latitude, longitude. Okay. Now, this is a totally free tool. If you build a line graph, you can visualize and troubleshoot and walk people through your logic and your decision tree. Let's talk about A to A real quick, and I'm going to give you a demo of A to A, okay? And you're going to be some of the first people to ever see this in action because this came out April 9th. It's April 16th. So 7 days ago, this protocol was announced. And this is agent interoperability. There's everyone's behind it. Embracing agentic capabilities, build on existing standards, secure by default, long-running tasks, modality agnostic, right? And there's lots to read on this. But if you just go into the GitHub repository, so before we go to the GitHub, there's a link here that says A to A Heart MCP. Too long didn't read. Agentic applications need both A to A for the agents and MCP for the tools. Your agent's going to be bound to tools, but we want our agents to talk to other agents. And we want our people talking to agents, not talking directly to things invoking tools. We want a layer of abstraction there. Okay? So if you get clone the A to A, it will come with a couple things, including a client. Now, what is A to A made up of? What you're looking at here is public on the internet. And I have two, the computer I'm working on now, forwarding out to the internet, and this Mac laptop here that you can't really see with a different agent. So I have two different agents, agent one and agent two, with different MCP tools. These are their agent cards. So this lets agents discover other agents and their capabilities, and it lets clients discover the agent's capabilities. So just real quickly before I continue, we have this line graph that has access to tools. We've seen the line graph, right? And we have a start and we have an end. And this can actually iterate here. We can pick multiple tools, right? So this is our agent, which is a Lang graph. This is the end. This is the start. These are our tools, and our tools are various MCPs, right? And the MCP itself has tools. What we have now is a layer above this, up here, where we have the A to A protocol, right? And if I'm a human wanting to talk to an agent, I talk to the agent. But what's really interesting is just like the World Wide Web, we can now start to have agents talking to other agents. So the user asks the question. Agent one says, sorry, I don't have that tool. But hang on. Let me go ask agent two, do you have the tool? Yes, I do. And it goes down into its line graph, talking to its MCPs, talking to a REST API or a database or whatever. And the data comes all the way back. The neat thing is this is over the World Wide Web. Agent one could be in Toronto. Agent two could be in Singapore. Now, is anyone kind of a step ahead of me? Think about all the agents these agents can start connecting to, right? So I have agent one, agent two, agent three, all the way up to agent 10,000, agent a million, 500,000 agents, and they all make a mesh together. Now imagine UCLA's agents and MCPs and tools talking to Stanford, talking to Michigan, and then we overlay General public now can start to talk to your agents, the university, the academia of America. And then you tap in healthcare providers looking at your research in cancer. This is how we solve cancer, in my opinion. Agents hyperconnecting the global infrastructure through an open web infrastructure. So before I lose anyone here, and I'll take some questions, let's take a look at this. So this is inside of the A2A repo, and I'm in samples, Python, hosts, and there's a CLI example. Why I use this is because I want to make sure my agents in the cloud adhere to the A2A standard. So when I run the CLI tool that Google provides, it's going to discover that agent card. Okay? And if we look closer at the agent card, I didn't really spend a lot of time here. It's got the name, a description, a version, the URL, an endpoint, the methods, and then it has capabilities. A to A, true. This can talk to other agents. Tool use, true. It has access to MCPs. Chat, true. And then these skills are the MCP tools that I've discovered dynamically, that I build this agent card dynamically. So now every tool that I've discovered shows up as a skill that this agent has. Right? So let's ask it a question here. I'm going to say, this is really neat. Remember that I have a second agent over here. My second agent has something called Selector. That's the company I work for in our platform. And I can ask it questions about Selector. The agent I'm talking to, this agent here, does not have the Selector tool. It has Cisco tools and other tools. So what I can do is say, can you ask Selector about device S3's health, and then send me an email report to, I'll just use my public email. Whoops, geez, I didn't want to do that. So let's just try that. So I can show you what's happening here. This is my A to A adapter, and it's received this request. So it says, I need the URL of a peer agent. So it'll do that. It'll say, I'll do that, and I know how to do it, but I need the address of my peer selector agent. So what I'm going to do is I'm going to give it the address of my peer agent. And your peer agent is that. Now you can't see it, but here, over here on my Mac, agent 1 over the internet has made a call to agent 2. Agent 2 is now using its Selector MCP tool to get the network information back. It will send it back over the internet to agent 1, which then should hopefully send me an email. Now, this part here, I agree, it should already know my peer agent, and I'm going to refactor my code a little bit tomorrow, so that way my agent automatically discovers the peer agent, and I don't have to tell it, this is your peer agent. But that's going to, so here we go. Check this out. The health device is failing, blah, blah, blah. But I don't have a selector tool here locally. None of these MCPs are selector. That agent went to another agent to get the data. Agents are working together to solve my problem. Now, if I go to my email, I bet you there's an email sitting in my Gmail from agent 1. And there it is. Now I have to work on this. This isn't perfect. Ideally, agent 1 would take the answer from agent 2 and make the email out of it. Looks like a bit of an order of operations issue here, where it sent me the email before it had the response. But I'm not really concerned about that. The fact that I'm talking to agent 1 is talking to agent 2. The 8A repo, yeah, it's So my code is all available. If you want to find my code is github.com/automate your network. That's my repo. And Google 8A is easy to find. So we have 20 minutes, and I'm happy to give you back some time, but I'd love to hear your thoughts, questions, comments. You can type them up or you can ask me over the microphone. Thank you for your attention and your time. I hope you thought this was interesting and give you some ideas for your hackathon projects.
Yeah, thanks so much, John. That was really a phenomenal presentation. And I was personally curious about what got you into learning about like model context protocols and like I know you're talking about like the history and all that, but I mean, when did this really start to kind of kick off this kind of terminology and like the uses of this?
So it's actually funny. A lot of these things rise out of necessity. So I have been doing AI development, as you know, for a couple of years now, and it was hard. There was no standards to follow. There was no guidelines to follow. There was no protocol to develop against. It was like I was doing things one way. My friends were doing them another way. You were doing them your own way. How do I get my agents to talk to your agents? Oh, well, I didn't do it that way. Oh, you've got to change your code to make your agent talk to my agent. There was a lot of, I call it friction. And now we can eliminate some of that friction because if your agent and my agent don't talk together, it's likely because one of our agents is not following the protocol. And that's easy to solve, right? Or if we both agree, here's the terms of agreement that we're going to develop these agents so that they work together, so that maybe American Airlines and Air Canada can have agents that can work together because there's no because there's a standard. The world has agreed to doing it a certain way. Now, I think of some dark times when there is competing standards. If we think about, you probably, no one here knows about VHS or Betamax, but what about Blu-ray and HD DVD, right? There's certain times when there's competing standards, and let's say Sony backs one standard and Disney backs another standard. Do you know who that hurts? It hurts the consumer. Because when I buy a PlayStation 5 and I can't watch Disney movies on it because it doesn't play their standard, now I've got to buy an Xbox. You know, like, do you know what I mean? Like, it's so limiting unless we all play on an even playing field. And I think these protocols are a necessity. So I think that I honestly believe there's going to be a boom. Take here. I know it's funny, but if we take email, right? Think about how much money has been generated from the ability to send electronic mail. That's all from one protocol, SMTP. Now, Microsoft had Outlook and Exchange. Exchange was the server and Outlook was the client. They probably made $50 billion off of those two products alone from one protocol to send email. Now, what are you going to do now that there's these protocols for artificial intelligence? It's a real opportunity right now. It's a gold rush, you know? Sorry, ADK, I'm not necessarily familiar with ADK. Let me just do a quick Google here. I'm just getting some questions. ADK versus MCP. So ADK is Google's agent development kit. So ADK is, so you know how I showed you a Lang graph and the visual and we did all the Lang graph stuff? That's my toolkit I use to develop agents. ADK is Google's own development toolkit that develops MCPs and develops agents. So they're not in competition with each other, they complement each other. So if you wanted to use ADK to write your agent, you totally could. I like to use LangGraph, although I am going to be exploring the ADK in my own time, because I think it's important for us to try different approaches. Great question. Yeah. Thanks, Taiyu. I appreciate the comments. Thank you. That was very nice. So I encourage you to connect with me on LinkedIn. Let's make a connection on LinkedIn, everyone. And if you have any questions or come up with something later, or if you hit some snag and you try to use some of my code or anything like that, don't be shy. I am a very open person. I do like to help people. I think that this is very important. And I'm just thrilled that Bruin AI has a club like this. It's really, really positive, and I think it's going to really reflect well on your resume. I really do. So that's that's me there on LinkedIn.
Yeah, and would you mind us sharing your LinkedIn on the Discord resource channel? We have a Discord
Sure.
with like 100 hackathon members, so I'm sure that like if they have any questions, they can go ahead and reach out to you on there.
So there you go. You could make an MCP for your research Discord and have a natural conversation with your research Discord through an agent. How about that? All right. Well, thank you so much for having me, everyone, and best of luck on your hackathon. And let's stay in touch.
Thank you so much, John. Thank you
All
everybody
right.
for coming.
Thanks. Take care.